Hello everyone, in this video we will be going to discuss the problem add 1 to number. So the problem description is given a non-negative number represented as an array of digits, add 1 to the number, that is increment the number represented by the digits. For example, if we have an input like 1 2 3, so the number is 1 2 3, that is 123. So we have to add 1 to this number, so it will become 124. So we have to return that output as 124. So let's understand the test case first. So this is the test case. For example, A is 123, but the number is 123, as this is represented as an array in this question. So we have to add 1 to this number. So 123 plus 1, that is 124. We have to return the output as an array of 124. So the solution is very simple, but we have to look for one special case, that is when the digit is 9. If the digit is 9, we know if we add 1 to this will become 10. That is for this digit, this will become 0 and one carry will be shifted towards the left. So we will replace the digit with 0 and proceed in similar way. For example, if we have first as 9, so we will replace it 0, and if it is another 9, then we will also replace with digit 0 and then proceed towards the left. We will see when there is an edge case. So when the case is 2 is when digit is not 9. If the digit is not 9, for example, in this case we have digit as 3. So we'll simply add a 1 and break from the loop. That is, if we have 3 here, so we will add 1, it will become 2514, and we will break as it is not 9, no carry will be shifted towards the left. So there is an edge cases. So edge cases are case 1 when all the digits are 9. So we will simply do is we will replace the digit 9 with 0 and move on. If we reach the index 0 and find that this is also 9, so we will set our flag to true and add 1 in front of the array list. For example, in 9999, so what we'll do is simply 9 replace it with 0. Another 9 we will replace it another 0. Another 9 we will replace it another 0. Next another 9 we will replace it 0 and set our flag as true. After the loop gets over, we will see that if our flag is true. If our flag is true, we will append 1 in the starting of the list. So this was the edge case 1. For the edge case 2 is, for example, if we have 0 1 to 4, that is leading zeros in this case. Like in this question we have mentioned that, for example, this can the output have zeros before the most significant digit, or in other words, is 0 1 to 4 a valid output? And they have said no. For this purpose the question, the answer is no, even the input has zeros before the most significant digit. So we have to remove these leading zeros. So we have to do is simply find the answer, like up from above step I will show you the code. So simply find the answer, for example 0 1 to 5, and we will check if our answer contains leading zeros, so we will remove from the list. So let's see the code first. So the code is I have initialized n as the size of the array and a boolean f as false, that is our flag for mentioning if the starting digit is also 9. So I will iterate from the back, and if I get a 9, if I get a 9, I will see if the it is index 0. If it is not index 0, I will simply set it as the digit as 0. And if it is not 9, I will simply add 1 to it and break from the loop. So I have told you before, if our flag condition is true, we will append 1 in the starting of the list. Otherwise, we will not do anything. I have initialized int k is equal to 0 for this. This thing is completely done for removing the leading zeros from the solution. So we will return our final array. So the time complexity and space complexity is the time complexity is simply a big of n, as we are not doing any other big operation, like we are just iterating from it, if checking for the flag, and this while loop can get at maximum at n minus 1 or nearly n times. And talking about the space complexity, we are not taking any space, we are just utilizing the input array itself, though. So the space complexity will be big of 1. So time complexity will be big of n, and the and the space complexity is big of 1. That's for the video.